Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter number 1 of our Marine Auxiliary System class. In this chapter, yes, we are going to talk about the rigging, and we are going to analyze what is the meaning of rigging, and we are going to check carefully the different type of rigging, depend if the boat is a power boat, if the boat is a sailboat, or if the boat is an airboat. In all of those different type of boats, we are going to analyze the rigging, the recommendations about the rigging. The people normally think that the rigging is basically tied a little couple of wires, a little couple of cables, but the rigging is more than this. Mr. Rodriguez, what do you think about rigging?
Danny, rigging is not as simple. The people think that rigging is just a couple of cables.
No.
It's more than this.
Absolutely. I mean, think about it. You got to run, if it's a two-stroke, you got to run oil lines, you got to run battery cables, you got to run the main wiring harness. If it's not fly-by-wire, then you got to do the shift cables. You got to make the shift adjustments.
Correct.
If you have steering cable or hydraulic steering system. There's a lot that plays a part, because what happens is if you don't do it right, the customer is not going to be happy. He's going to get in trouble. Hey, you know what? Because like some like for instance Suzuki has a special harness that has to have power of the motor all the time. If that's hooked up directly to the battery. If it fails or it corrodes, the motor will never start.
Yeah. For that reason, the majority of the manufacturers, they have a special exclusive catalog only for rigging, no?
Correct. Every manufacturer has their own rigging catalog. And it has schematics in it to show you.
Schematics about the wiring for lights, for gauges,
your NEMA network, private network.
Correct. That's
in junction boxes, because Mercury uses junction boxes instead of like the hubs like the Emeralds do. And it's also important to understand where you put the rigging stuff.
Correct.
Because if you, for instance, that hub that I was showing you, it burnt out because whoever rigged that boat put it in an area that water was falling on it. So when you do rigging, you need to put the stuff tucked away that the water's not. You're not going to put it at the bottom of the bilge.
Correct.
You want to put it as high as possible, tucked underneath on the bulkhead as far as so when the hatches get water, it doesn't drip water on it.
You can lose the warranty of an equipment basically because the installation is wrong.
Yeah, and you know what? If the installation is wrong, guess who pays for that? The dealer.
Not
Evinrude.
The dealer.
Because you as a dealer are certified and responsible to do it the right way. So that'll be on the marina. So if you're working for someone and you do that wrong, guess what? Who you're working for is going to pay for that. And you're not going to be very happy.
Correct. And if you try to apply for the warranty, I suppose that the manufacturer immediately send the inspector of the insurance company.
No, you have to send the parts back, and they'll inspect it over there.
Oh, okay.
Unless it's a catastrophic failure or some major meltdown that no one's not really 100% sure, then they'll send someone here to check it out. But most cases, they want the parts back, they look at it, they confirm that was the problem, they either pay you or they don't pay you.
But in some cases, they can say, hey, your installation is wrong because the recommendation is according with this is, and your installation is completely different.
Absolutely.
No warranty, bye-bye.
Absolutely.
That's critical, no?
Absolutely.
Follow the manufacturer recommendation, especially in rigging, is a critical point. Correct. And once again, each manufacturer have your special rigging catalog. No?
Absolutely.
Okay.
So you know the components that you need to use, how everything is going to be wired, like the pictures that we took in there, you've seen that, they have the format, the schematic, how it runs. Listen, that's why in basic electrical, you need to know how to read a schematic.
Oh, of course.
Because whether it's a schematic for wiring or it's a schematic for rigging, you have to understand what schematics are.
And I suppose that be a distributor, be a dealer, is not simple. It's not only, I need to sell some amount of equipment per month. No, you need a lot of training for you and your technicians.
Absolutely.
If not, you make a lot of mistakes.
Well, here's the deal. Every time I sell a new motor to a customer, I have to do a PDI, which is pre-delivery inspection.
Correct.
And I have to sign off with my dealer name certifying that I did exactly everything right. So if there's a problem with a rigging issue, they know who it went to.
Yeah, because what happens if the customer visit another dealer in other place and they, hey, who installed that engine? What about that cable?
Absolutely. Absolutely.
What about that?
This was done wrong.
Correct.
And they'll report it every, they'll look back in the paperwork, they're gonna say, oh, you PDI, that you proved this, it's your
Correct.
signature,
Correct.
you're responsible, and then it's on you.
Now, guys, you understand why rigging is critical. Rigging is more than tie cables.
Absolutely.
Uh,
So it's
it's-
actually very important. Rigging is really like an art as well. It's
Okay,
not just
it's an
rigging
art,
because
yeah.
you don't want the rig and all the wires hanging. No, you want to make it look nice. You're professionals. That's what we are.
Correct.
We're professionals. So if you're a professional, you do a professional job. Make it nice and neat, everything clean. So when the customer looks at it, even though he'll never look at it again, he'll be like, wow, that looks good.
Yeah.
Makes him feel good, makes you feel good, and then you know you did it right. And then at
Yeah.
the end of the day, out of all this is being done, the number one thing is the customer's happy.
Yeah, I like that expression. It's the art of
It's art.
rigging.
Electrical's art. I
It's-
love art. This is an art. You
Of
have to
Of
you,
course.
you have to take pride in what you do.
Correct.
If you do a shabby rigging, everybody's gonna be like, who did that rigging? I mean, because let me tell you, bad news travels fast now. Everybody says, oh man, they did good rigging. Who did that? Oh, really? Look at did. Oh, they did good
Yeah,
work.
yeah, yeah.
Oh man, who did that? Really? Look at I wouldn't take my boat there.
Yeah,
You know, that's
that's true.
That's
That-
reality.
That's correct.
It's
It's an
like
art.
you want some shabby mechanic working on your car. Then when you look at the car, he fixed your car, and there's wires cut here,
Yeah,
wires
yeah,
hanging
yeah.
there. You'd be like
Yeah.
scared.
Yeah.
So it's the same thing.
It's exactly the same.
Same thing.
All right. Thank you. Welcome to the rigging world.
Yeah, rigging is more than this. Rigging is a critical part during the process of installation of new equipment in your boat. For that reason, I recommend be careful with the rigging, check the manual, check the manufacturer recommendation, ask to the manufacturer before you try to install a new equipment in your boat. This is a critical consideration. Okay, we are going to start our chapter number 1 with the rules of navigation. Navigation lights. The port side and red is a red color. The starboard side light is a green color, and the steam drive is 135 degrees is white color. This is exactly the configuration for those navigation lights. And of course, if you have the steam light should be white color, should be white and shine, and 67.5 degrees for each side, in total 135. Yeah, this is another perfect example of the configuration of those navigation lights. Don't forget the navigation lights on front, red and green, on top white color, shine white color, 360 degrees. And this is the recommendation depending on the length of the boat. The masthead lights are white and shine from 112.5 degrees on port side and 112.5 degrees on starboard side. Both of them. Yes, we have a steam light, 127 degrees in the back, and we have the masthead light, and in front, in each side, we have the navigation lights, red color and white color. That's a very, very important. And this is a perfect picture about the lights for sailboats and powerhead boats. Powerhead boats over there and sailboats over there. Alright, the installation of those lights is not difficult. The most important consideration is where is coming the power for those lights, and this is the recommendation. In the majority of the boats, you have a panel. You have an exclusive panel dedicated for navigation lights. That panel for navigation lights should be connected directly to a constant positive bus bar or to the house batteries. Right now we are going to talk about that. In some boats you don't have this specific panel. In some boats you have toggle switches for navigation lights, and those toggle switches on the console, on the dashboard, receive the power from that constant positive bus bar or from the positive of the house battery, depend on the configuration of your boat. In other boats, the navigation light should be powered constantly, all the time. Exactly the same like other element that should be powered constantly. You remember? Yes, the bilge pumps. The bilge pump should be another group of elements that should be connected constantly to the power. And other, exactly, the fire suppression system. Correct. The fire suppression system is a group of equipment that should be powered constantly, all the time. Yes, fire suppression system, bilge pumps, navigation lights. Other one important. I recommend connect that element constant, the radio, the VHF radio. The VHF radio should be connected directly with power all the time. Doesn't matter if the rest of the breakers, the switch selector breaker, the switch selectors, the red one, you remember that one? Doesn't matter if that switch selector is off. Okay? Navigation lights, bilge pumps, fire suppression systems, VHF radio, and other one that every day is more popular, being connected directly to the power. Yes, the router for internet, because today the majority of the equipment should be connected to internet every day during the day to update different softwares. Correct. That router should be connected directly to the power. And other element that should be connected with constant power. Other element with constant power. The cameras, the CCTV, the cameras on the boat. They should be connected with constant power. All right. Those are elements that I recommend be connected directly. And of course, if you have that connection, I recommend the fuse. That fuse here is important. That fuse is very, very important. The fuse to fit those navigation light switches. Okay, this is basically the theory related with the navigation lights switches. We don't need a special consideration. You remember we did the wiring of those elements in the chapter 7 and the chapter 8 of our electrical handbook. In that chapter, I explained in details the procedure to connect all the gauge in the dashboard, the ignition switch, and all the elements in the dashboard. The navigation light switch is part of the dashboard and should be connected over there. Okay, my friends, this is the theory related with the installations about navigation lights. Okay, then the next part of this episode will be dedicated to the cables, the control cables for throttle, control cable for chip drive. And we are going to analyze the control cables in power boats with center console, power boat with side console, and different type of mount units, center mount, side mount, with cables or electronic that the harness is connected to the NEMA backbone. We are going to analyze all of those systems one per one, step by step. We are going to visit the marina of Mr. Rodriguez to do that study. We are going to start right now checking the different type of cables used for controls. Danny, now we are going to talk about the adjustment in mechanical systems.
Right.
Basically, we have three type of cables, no?
Yep. You have one here is the Evinrude. And then you can make the adjustment from here to set it to how you want.
Because the rod is fixed.
Yeah,
no?
This is fixed and this is fixed. This goes in the control box and it's fixed.
Okay.
And then this one here goes to the motor. So if you need to make the adjustments, you move the barrel. And then once you make the adjustment, you clamp it. It has a clamp special with 3/8 bolt. It clamps and it holds it. So that's why it has these ridges, so it won't move.
Okay. You clamp it over there.
And this is the Evinrude Johnson version of that.
Evinrude Johnson.
Okay.
Perfect. Danny, this is the mechanism to lock the system.
Correct.
Because this is the element that is over there on
Right.
the block. And you have a couple of dents over there.
Yep.
And with those dents, you fix it this one.
Yeah, so if you look this way, it locks. It can't move because remember it's against another piece here, through bolted with a 3/8 bolt.
And
see how it only moves a little bit, but you can't move much.
Okay, yeah.
Okay,
you
that's
have
how
other one equal in the other side.
Correct.
Okay, when you release that one, you are free and you
Yes.
can adjust. And once again, immediately you remove the mechanism, you are free.
Yeah, I loosen this bolt so it's got enough room, and I normally don't take the cable out. I kind of leave it in there, and then you see how you can take a screwdriver, move it this way, or needle
okay,
nose.
perfect.
You can move a needle nose either, and you make the adjustment. Once you make the adjustment, you lock it back up. This doesn't
And you
move.
put it back then the
and that's
bolt.
it.
Okay.
This is a 130 Evinrude E-Tech G1 first generation.
Okay. A lot of tips.
Yeah, it's a fuel injected motor. Just has injectors like everybody else. Has the new style ignition coils. and then here's the cables like you saw that what we were explaining. So I just want to explain something. When you're doing cables, remember they're not set right from the factory. You have to set it. So what happens is if you have this cable too far forward, see how it puts pressure there?
Pressure, and that one, the plastic is not moving.
Yeah, the plastic is not moving. So what that happens is, remember, this is fuel inject. There's a throttle position sensor. So the throttle position sensor at close should be 0.5. Because it's touching, now you're giving more than 0.5, it's going to give you a code. And you have a code right away, a TPS fault.
And so, it's basically here.
It's there, because this is all, your TPS is here and it's controlled. This is your throttle. So that's how the engine knows where it's at in open closed throttle to advance the timing to give it fuel. So when you make the adjustment, you want to make it to the point that's not touching but close enough that you can spin this. You want to be able to spin.
And this is basically because the calibration here is not appropriate.
Well, that calibration, remember that barrel like I showed you in the other one?
Yeah,
Okay, so like we were just saying, so the adjustment now, you loosen that 3/8 bolts, it takes the pressure off of this, and then you make the adjustment. So remember, if it's like this, it's got too much throw. So then I want to go reverse, so it pulls back, and then makes the adjustment. And then once it's there, then you hook this up, and now you know you're not going to get a code.
Okay, the tip is this one free.
So but you got to make sure that it pulls back. Now I'm gonna move the throttle. I want you to see what happens. See how it moves? So look, this is how it makes adjustments. So give it full throttle. There you go, that's full throttle. See how it moves all the way, touches up here. Go back to neutral. And then see now it's not touching. So you make that adjustment. So here is where you make that adjustment. That's the only way you could adjust it, because this is an OMC cable.
The only way is here, no?
It's here, correct.
Because you release the pressure here, and right now it's free to adjust. And once again you clip.
Correct.
Okay, perfect.
Okay, and the same thing applies in the shifting.
Exactly the same.
So let me give a quick rundown.
Okay.
So when I'm putting new cables on this, because remember, it's really hard to adjust the shift when it's not in the water because there's no pressure on the prop.
Yeah, of course.
So what I do is when it's in neutral, I'll spin the prop, then I'll put it in forward, and then I want to make sure it locks. Let me show you.
Now it's locked.
So now it's locked, right?
Correct.
So now you know in forward we're good. So what happens when you go reverse and it starts going and it still moves but it's clicking? Well, that means you need to make an adjustment. So by moving that barrel, you make the adjustment.
Okay.
And then you redo the process. Okay, it locks in forward, it locks in reverse, in neutral it spins, no sound.
Now it's free.
So in neutral, you're listening. You don't hear
no.
because if it's doing the clutch dog is touching.
And you damage those.
And you damage the clutch dog.
Yeah.
So that's why it's important that when you do the test, you do this test. And then the final test is taking it to the water. Make sure you put it in forward. When you put it in neutral, it really goes in neutral. Because sometimes you might have it too much forward, and then you got to go reverse to get neutral and then go back to neutral. That's why the final adjustment has to be done in the water.
Okay, we are going to repeat. The first step is adjust on the ground.
Adjust on the ground, make sure it locks in forward and locks in reverse, and then when it's in neutral, you don't hear any clicking sounds.
Correct. And after that, you put on the water.
Put in the water and do the same test and make sure everything is proper. It goes in the gear right away. Because sometimes, here's another scenario. You put it in forward, but you have to give it a little bit more forward to go in forward. And then when you go in reverse, it goes right in reverse. Well, it's not right. It's as soon as you put it in forward, it should go right in the forward. You go to neutral, right in neutral. When you go reverse, it goes right in reverse.
Correct.
So then you make the adjustments accordingly.
Correct. And the adjustment is basically here.
Basically here on this model and the Merc Cruiser, which has a little different one.
Correct.
But if it was a 33C, the cable has a cable length.
Yeah.
I'm going to show you right now. In the picture above, you'll see that
calibration. All right. That's wonderful. But at the end of the day, it's not complicated.
No, it's not complicated. It's just you do the test on land first, and then you do your final test. You always have to do a final test in the water because you do not want to give a boat back to a customer that complains to you, hey, it goes in forward but no reverse. but it did it on land. But remember, there's no pressure against the
Of course,
prop.
the pressure is critical.
It's critical.
For that reason, the final test is
Always in the water.
on the ram.
That's if it runs good for you in the water, it's going to run good for the customer.
Yeah. Right. And what about this one?
This one is the typical mercury cable.
Oh, mercury cable.
It's fixed at the control box. And the adjustment on the mercury has this. It has a slot that you put this in, and there's a clip that holds it.
Correct.
And this is so you make your adjustments here. So this is fixed again.
Oh, okay, perfect. This is mercury.
This is a Mercury Mercruiser.
Mercruiser, inboard, outboard.
Inboard, outboard.
Inboard, outboard. Perfect. And this one?
This one is the same thing. It's 33C cable, but this is all fixed. It's fixed at the motor and is fixed at the control box. There's a little piece here. You make the adjustment, and then once you make the adjustment, you tighten the nut so it holds on.
This is only to tighten.
That's only to tighten. This is what it's called, 33C cable. This is a U-Flex mock cable, but they have Morse cables. But when they say 33C, it's like this.
Okay, it's used in what type of?
Yamaha, Suzuki, Volvo, OMC stern drives especially in the back, because the OMC stern drive. Remember, the OMC stern drive, the cable goes right to the outdrive.
Correct.
Same thing as the Volvo goes right up to the outdrive.
Okay, all right.
Our Cruiser goes right to the shift plate, which has a separate cable that goes to the motor.
Correct.
But this is all adjusted only by moving this. The other ones are adjusted by moving that.
Basically, in mechanical system, we only have those three type of cables.
So if you have like Morse controls and you have dual station, most of the time it's 33C cable.
Yeah. For dual control.
For dual stations.
Dual station, yeah.
Correct.
All right. This is the famous 33C cable.
Correct.
And what is the procedure to do the adjustment?
Well, first of all, you have, if you notice here, this has clips.
Yeah.
So you set it to where you want, to where it sits, and then you make your final adjustment here, and then you tighten this.
Okay.
You tighten this up so it doesn't move, so it won't move anymore.
Okay.
So the adjustments here compared to the other one the adjustment was back here. You only have 3 settings here, because this cable could be used for outboards, inboards, diesel, IOs.
It's used in different
and every different application. So there's different lengths. Like if this goes on a transmission, well, maybe the throw's longer, so then you would have to go as far back. If the throw's less, then you put it here, and then you make the final adjustments here.
Perfect.
So that's why you see the slots. And so when you put this here, there's a clip that goes in there.
You put the clip over there.
Yeah, there's 2 clips, like a U-shaped clip.
Yeah.
And then when you have the clip on the other side, you bend the tabs out so it doesn't move.
To avoid that they move it. Perfect. And you do the adjustment easily here, and you
tighten it there. Because what happens is if you don't tighten this, the vibration will.
Okay. Yeah, I know. Perfect. That's simple, no?
Simple system.
And now we are going to analyze the different type of consoles. There are center consoles, side consoles, and the controls for those consoles. There are top central consoles, single or dual for dual station, with cables or wireless connected to the NEMA backbone. And we are going to analyze each type of controls depending of the console.
Danny, this is the typical control mechanisms, mechanical, for fuel, for shift.
Yep.
That's too simple, no?
Yeah, this is it's called a surface mount control box.
Okay.
Because if you look at it, this mounts on the side of the
gunnel.
surface,
yeah,
okay.
Perfect.
So you have your cables that come in here. This is your throttle only. So if you watch, this is your throttle. That's so when you first start it.
Can you move it, please? Perfect. That's the throttle. Okay, and the adjustment is exactly the same?
And the adjustment here, remember I told you the 33C cable? This is a Morris 33C cable. See how it holds the groove, keeps it stationary?
Correct.
Here's where you make the adjustment. See the nut's nice and tight.
You lose the nut.
And then you have a circle clip just to hold it onto the shifting mechanism.
Only to hold it.
Okay?
Perfect.
And then the bottom one is your shift. That's forward. See? Forward, I'm giving it gas. Neutral, it's going back to neutral. Reverse, and then I can give it gas and reverse. Neutral.
Can you explain in what moment the gas starts?
As soon as you put it in forward like this, it's already going in gear, but no gas.
Correct.
Then you start giving it gas, then you start moving it.
Correct.
And then when you put it here, it goes to a detent, locks in place.
Correct.
And this one here, you have to hold this because it's protection, so you can't accidentally bump it into gear and someone gets hurt. So when you press it to go reverse, it goes in reverse, no gas. Now it gives gas.
The gas. Okay, that's
Neutral.
perfect.
Now it gives gas.
Now the gas. That's okay.
So you can make adjustment here and at the motor.
What about this, Danny?
Now this is your tensioner. So like let's say this cable, this is too loose, you can tighten that so if you hit a wave, it doesn't go give you more gas. So it kind of keeps tension on it. That's kind of a feel deal for the customer.
Correct.
Some people want it looser, some people want it tighter, but this is so it doesn't move on you.
Okay, this is the typical mechanism, the mechanical mechanism. What about this?
Okay, so this is what they call a top mount control box.
This is not a side mount, it's top mount.
This is a top mount control box, and it's because it's on top. Okay, so same thing applies, but this one you don't have to have anything, and you give it forward, neutral, reverse. You hear the D10?
Correct.
So the cables on this one goes in here.
The cable goes over there. Yeah, that's perfect. That's perfect. One cable enter here, goes over there,
Right.
and the other cable enter here
So
and goes over there.
When you shift it, we'll do. See, I'm giving it throttle, neutral, reverse, forward. See the throttle?
Correct.
Now, do you know what that's for?
That's the neutral safety switch.
That's the neutral safety
That's
switch.
the neutral safety
So the
switch.
purpose of that neutral safety switch is so you do not start it in gear.
Correct. Avoid that you start in gear.
And this ties into your starting circuit.
Correct. In the yellow-red cable.
Correct.
You interrupt the yellow-red cable with the neutral safety switch. And this is the mechanism because this is a normally open switch.
Correct.
Excuse me, normally closed switch.
Close.
Perfect. That's wonderful. We have one cable here, other cable over there, and this is the mechanism for the top mount
Top
system.
mount control box.
This is the top mount dual station.
Dual engine. So the same thing we saw on the single top mount.
Correct.
This is a top mount dual station.
Dual station.
Now,
okay.
on dual motors, there's no such thing as surface side mount. Okay, they did make it at one time, but they don't. I don't think they make them
okay,
anymore.
okay.
Now everything is top mount. So this one here, same thing, in gear, then you give it gas.
Gas.
Neutral,
Neutral
in gear, and give it gas.
and gas. And the
Now-
same for the other one.
And for the same for the other one. So now this one has two buttons and one button here. This button here synchronizes both engines to go up or down
Up and
at the
down,
same
both
time.
engines at the same time. And this one individual.
individually. Each engine individually. You can like sometimes what happens
nice.
is that you have one engine that's faster than the other.
Uh-huh.
So sometimes you make adjustment by touching the individual switches.
But in similar that in diesel with dual extension, this element synchronize the RPMs in both of them?
No, this will not synchronize the RPMs. This
okay.
one is only for trim and tilt.
All right. Okay. Perfect.
The digital throttle does
Synchronized.
that, which I'm going to show you now. I have a digital throttle that I'm going to show you. It's a single engine, but it's going to be kind of similar to the dual purpose.
Okay, perfect. What is the name of that?
This is actually for a Mercury Mercruiser. This is the Quicksilver 3000. This one here is a okay control box. I like the older style. This has it's a little more finicky, but also is very good. It also has a neutral safety
the neutral
switch.
safety switch to interrupt the cranking system for both engines.
Both engines,
because
correct.
you have one
4
engine and the
cables.
other engine. 4
And
cables.
this one here is your synchronizer module.
The model of synchronization.
So this does both motors at the same time, and then you can bypass it and you do the individual motors on each time.
And if you have a problem, you need to replace that unit.
Yeah, you can kind of hot wire if you're out in the Bahamas and you have to do it. You could do it, but this is the module.
That's the module. Danny, this is another great example of an electronic control system.
Yep. So what they call fly-by-wire.
Oh,
There's no cables. It's only digitally controlled.
digitally controlled. Okay, how operate that system?
Okay, so I have one here for a single engine, and you have your harness here. This is your private network, because when you're dealing with fly-by-wire, you have the NEMA, which is the public network.
Correct.
And then you have the private network, which is to the engine itself.
This is the private network exclusive for the engine.
Correct. And so this one has the same thing. It's a private network. So all your wiring harness is in this. No more big wiring harnesses.
Nice.
So you're just running one cable back to the bus system. Okay?
Okay, perfect.
And I'll explain the bus system in a second. So this one here, this is a dual engine. So when you're in neutral, it's normally not flat. It's just we have a low battery right now, so it's flashing. So when you put it in gear, it tells you now it's in gear.
Okay.
In neutral, it's in neutral. In reverse, this has an indicator.
Okay, perfect.
This one here has the same thing.
The same indicator for forward and reverse.
Right, for single, this is for twin. Okay, some now they have one that's completely black, which is the basic model, which is still fly-by-wire, but it doesn't have all these features. Now, if you notice, this has an RPM feature and that has an RPM feature. check this out. You know when you're trolling to go fishing, you want to give it a little bit more gas. You give it a little bit more gas.
Yeah.
You press a button, 50 RPMs. I want more, 50 more RPMs. I want more.
And you
50,
don't need.
and you don't have to move the throttle.
Oh, nice, wonderful.
That's on the single and the twin. Now the twin has a cool feature. Okay. Now you have an N here, means neutral. So you hit this, it's only neutral, throttle and neutral. And then in the light, will be indicating, and then you press it to go back to so you can go in gear and out of gear.
Here is exactly
it's
the
same thing. You hit this. Oh, that's because the battery's low. You hit this neutral, and it'll tell you that it's in neutral, and it won't go in gear. Okay.
Yeah.
Now, same thing. You can go 50 RPMs up to 400 RPMs in one direction and 400 RPMs in the other direction. And then you have both engines, individual engines to trim up and down.
Perfect.
Now this sync is a cool feature. So let's say you're driving and you know how you want to give it gas, you give one, you got to move. Well, no. You hit that sync, and now one control controls both engines.
But then, and you eliminate
that one.
Oh, wonderful.
So now when you're going to go to dock, you have to bring this back up. You hit the sync, and then now you have control on both.
Correct.
But when you're just going straight now in the ocean, unless you're going to the Bahamas, you hit sync, put this down. This controls both engines.
With only one harness.
With one harness, right.
Okay, perfect.
And then when you put it in neutral, and not neutral, you put them together, hit sync, and then you're back to its original state.
Okay, this is a completely electronic system.
This is a fly-by-wire set, fully electronic.
Okay.
This is the brain. The brain. See, the engine has a brain computer, and so does the control box. It has a computer.
Yeah, perfect.
So your steering system codes and all that will be on this instead of the engine.
Okay. Danny, and what about the connection in between this point and the engine?
Okay, so what I'm going to do is I'm going to break out a book, and I'm going to show you schematically, and to explain it.
Station is connected with the hub over there, like this. And in the back,
you have another
one
hub
for each engine, other for each engine.
Yeah, because you have another hub that feeds from one hub to the other, and the engines go into that hub.
When you have more than two or more than three, you connect other one in series with this. That's perfect, Danny. Great example. You replaced that one because it was burned.
Yeah, this one got caught on fire, so that's why we replaced it.
Oh, it's burned. And immediately internally it's damaged.
No, it's a circuit board in there.
When it's in good condition,
the green light's lit up. So when you turn the key on, the light should be on.
Oh, nice. Oh, perfect. This is not expensive, no?
Yeah, it's $100 and something for that.
All right, that's okay.
It's not bad.
It's not bad.
It won't break the bank.
Yeah.
But you see how easy to rig. It's very simple rigging. It's a plug-and-play system.
It's a plug and play, yeah.
It's a plug and play.
But now I understand when you say that this is the private network.
It's a private network. That's for engine, and then you have the public network. You have the T's. See the T's?
This is the NEMA.
The NEMA system.
That's the NEMA system.
That's why they call that the public network.
You integrate those gauge with the private system.
That's going to be to the public system, because there's a harness that goes on the engine.
Yeah, with the public.
Which I'm going to show you right now.
Yeah, okay, good. Danny, is possible if I have a boat with a mechanical system with cable, can I convert into electronic?
No, you can, but it'd be too expensive because the computer's different and then the wiring's different as far as the harness, because you would use, if it's a mechanical system, you're going to use a regular wiring harness like the typical that we've been using forever.
Correct.
And, but you can still read on the public network, because the private network is specifically for a throttle body. Not for the throttle body, the fly-by-wire. But if you want to read your engines on a GPS and your NEMA system, all you need is that harness that we just showed you that hooks up to the computer,
the gateway,
and it goes right to your electronics, and you can bypass it. Everything can still be mechanical.
And you use the same screen for the rest of the electronics.
Absolutely.
Oh, that's okay.
Absolutely.
All right, but this is basically only to read the information, not to administrate.
No, it's only to read. You can't do anything. It's just for reading.
That's different. Right. In inboard diesels, there are kits to convert the mechanical system into electrical, like this one that we have on the screen right now. But this is not common in outboard.
No. Before there was fly-by-wire, the Teleflex made a fly-by-wire system. But what it was, and I wish I had some and I threw it away because we don't use them, but it had a box that the cables went from the motor to a box.
Correct.
And had a cable to the engine. That was the beginning
Yeah,
stages, and I really wish I kept that because that would have been nice to show.
It's a first step.
That was the first step. Remember, I mean, most of the videos that we've been doing, we've been showing from the beginning
Yeah, I
to
know.
where we are today. So
Yeah,
that
I
was
know.
just one step, and then I'll look for one to see if we can find
That-
one
that-
again.
that's-
That'll be good to show that because
Yeah.
that was the back in the, and that was problematic because what happens is when the cables got stiff, it would throw a code because the servo couldn't move the cable freely and would give you a code and then it wouldn't work.
Once again, I want to return to this one. You replaced that one because was burned. Why?
More than likely because wherever they placed this had too much humidity and water must have got in there and shorted it out.
Humidity. Right.
That's more than likely what the failure was from.
For that reason, it's recommended some
Dielectric grease.
Dielectric grease. Okay.
You should use dielectric grease for almost all your connections.
Correct.
You should.
It's recommended.
No one really does, but you should.
Should. Okay, that's perfect. And ground.
The grounding is in the system up front because you'll have a special harness that goes directly here, which feeds to your battery with a 3-amp fuse,
Okay.
and that provides it the ground in the system and the positive.
Oh.
Yeah, that ties into the
that's
system.
very,
Actually,
very
if you see in
important.
this, let's just go to a single one. You'll see.
Danny, and the case of the station should be connected to the bonding, to the grounding?
No,
Not necessary.
no, because the bonding's internally. There's a computer in here, so there's no bonding on the outside.
Really,
Yeah.
this is a computer, no?
It's just really the computer's in here.
It's in here. Okay.
This is where all the connections on the inside comes in.
That's okay.
Now, that like you were asking about see here,
Yeah.
this is where your power and ground's gonna come from.
Correct. Oh yeah, it's on the harness.
It's in the harness.
It's on the harness. That's the ground. Okay.
So you have, let's just say your system's not working. You have to check if you have power and ground.
correct.
You have a
correct.
bad ground, then you need to
Yeah, the
address
first
that.
step.
You need to That's why, again, I always tell you, process of elimination.
process of
Got to go to
elimination.
the source.
Exactly
The
the
source
same.
is the first thing you need to go to make sure that it's powered. Because if you're checking things and you don't have power to the source, then you're wasting
No,
your time.
no, no, no. Of course.
Okay.